Okay, now we get to talk about what happens when we change states. So matter undergoes a change of state when it's converted from one state to another. So the learning goal for this is to describe the changes of states between solids, liquids, and gases and calculate the energy that's involved. So it can't just be as easy as, oh, we're going from a liquid to a solid, solid to a gas, whatever. We have to do calculations too, and I know you guys love them, right? So melting and freezing. So a substance is melting while it changes from a solid to a liquid at its melting point. It is freezing when it changes from a liquid to a solid at its freezing point. And water has a freezing a melting point of 0 degrees Celsius. Okay, so melting and freezing are reversible processes, and you know that we can go from solid to a liquid or liquid to a solid, and that both is going to happen at 0 degrees Celsius. Okay, so that one seems pretty straightforward and easy, but of course when we get to more examples, it can get a little bit more complex. Evaporation, boiling, and condensation. Using water is a great example. Water evaporates when the molecules on the surface gain sufficient energy to form a gas. And it condenses when the gas molecules lose energy and they form a liquid. Okay, and so you can see the differences happening here at 50 degrees Celsius. Things are starting to change. So during evaporation, the molecules of a liquid are converted from a gas at the surface of the liquid. Using water boiling as an example. When the water is boiling, all of the water molecules acquire enough energy to form a gas, or the technical term for that would be vaporize. Okay, so they have enough energy to vaporize. And the bubbles of water vapor appear throughout the liquid. And you guys have all seen this as we're making mac and cheese, right? Or boiling pasta or doing whatever. So during boiling, the molecules of the liquid are converted to a gas throughout the liquid as well as at the surface. We have a couple other terminologies, and I guess these would be great for flashcards as well. We have sublimation and deposition. So when sublimation occurs, the particles on the surface of the solid change directly to vapor, and there's no change in temperature. Where when deposition occurs, the gas particles change directly to a solid. And so a good example of this would be dry ice. I don't know if you guys have ever had a chance to play with it. It's kind of fun. Burns your hands. Don't handle it without gloves, but it is a ton of fun. And so it goes directly from a solid to a gas. Okay, so that would be sublimation when we're going from the solid, liquid, dry ice to the gas. Okay. Here are some other examples. So we can use this actually to make freeze-dried food. So freeze-dried food is, I don't know, kind of weird. I mean, if you look at like moon candy and stuff, I mean, it was a big deal when I was growing up because, you know, going on the moon was a big deal. It still is a big deal. But they use this for freeze drying and long-term storage. So an example of this looks like peas. Water vapor will change to a solid on contact with a cold surface. Or again, the freeze-dried food, if you guys are preppers or do hiking or anything like that, the freeze-dried foods have a longer shelf life because they contain no water, okay, because they underwent the process of sublimation. On a heating curve, the diagonal lines indicate the changes in temperature for a physical state, and the horizontal lines, or the plateaus, that you can see here and here, indicate when it's actually changing state. So again, using water as an example, you know, we have our solid temperature here, and then we hit a point, our temperature point of 0 degrees, and then that would be the melting. And then we go to up to 100 degrees, and that would be when we'd start to boil and turn it into a gas. Okay, and this on the x-axis, we talked about axes before, is the heat that is absorbed versus the temperature in degrees Celsius. So heating curve diagrams like this, the temperature increases and changes the state as the heat is added. And so notice it takes a lot more heat to change the states. So you can see here, it takes a lot of heat to change the state from solid to a liquid, okay? Or liquid to a gas. either of these. So any of these long upticks are going to be the energy that is needed. A cooling curve is the opposite, a cooling curve. And this is going to illustrate the changes of state as the gas is cooled. And it uses the slope lines to indicate the decrease in temperature. And again, these plateaus are going to indicate when we have a change of state. So we have steam that can condense and form condensation to actually be a liquid now. And so then we have water, and then we have the decrease in temperature until we can get down to the freezing ice state.